Hello viewers. So we have this question that says using any conjugate acid and base pair, show that Ka multiplied by Kb is equal to Kw. Well, so we are taught to say we can choose any acid and base pair. So I'm choosing formic acid. Formic acid has a formula of HCOOH. So after choosing the acid, we are going to put it in water. In short, we are going to write its dissociation equation. So let's quickly do that. Dissociation of formic acid, COOH, when we put it in water, this will give us on the other side, we are going to have the hydronium ions added to the conjugate base, which is CHCOO minus. So this is what we have when you put formic acid in water. Now the next step is to write its Ka expression. So the Ka expression will be the concentration of the products. We have the hydronium ion on the product side, and we have CO minus. Yeah, so we have HCOO minus, the conjugate base, and then this will divide by the concentration of the acid. Remember, water is not included because it's in liquid form. All right. So now, after doing that, we're going to take this base here that has been produced back in water and also write its dissociation. So let's quickly do that. What we have is we're putting the base back. So we have HCOO minus. We're putting it back in water. And when we do this, what we are producing on the other side is the acid will retain its hydrogen, and then we're going to produce the hydroxide ions there. So when we are putting this conjugate base in water, water is acting as an acid and is going to donate a proton to the base, and it will produce this acid here. And what remains here will only be OH. So that's what we are producing on the other side. So our next step is to basically write the Kb. Since this is a base that we are putting in water, so our expression is no longer Ka, it's Kb. So this will also be the concentration of the products that we have there, uh, divided by the concentration of the reactants. So on the reactant side, we only have the base, conjugate base. So this is our Kb expression. So after doing that, the next step is to write the Kw expression. What we are doing is we are writing the water autoionization, meaning we are putting water into water, and then we'll see what we are going to produce. So let's have water put into water. When we do this, what we are producing on the other side is we're going to produce the hydronium ions and the hydroxide ions. So when you put water into water, it autoionizes itself, and then we are producing the hydronium ions and the hydroxide ion. So now the next step is to write the Kw expression. So Kw will be the concentration of the products as well, divided by the concentration of the reactants. But you should notice that on the reactant side here, on the reactant side, we only have water, and this water is in liquid form, so we're not going to include it here. So our Kw will just be the way it is, like this. So this is our Kw expression, like that. Well, so after this now, our job is almost done. All we have to do is we're going to now multiply our Ka by Kb. So this is what we are doing. Now our Ka in this part that we have here, you can see this is our Ka and this is our Kb here. So we are multiplying that by this. So let's do that. Our Ka is H3O plus concentration multiplied by HCOO minus concentration, and this is dividing by HCOOH concentration. Then we are multiplying this by Kb. Our Kb is HCOOH concentration, and this is multiplying by OH minus concentration dividing by HCOO minus concentration. So that's what we have there. Well, after doing that, we can see that this part that we have here, this part that we have here, and that part that we have there are the same. This part that we have here and this part that we have here is the same. So the conjugate base here and the conjugate base there are the same. We have the conjugate, we have the acid here and we have the acid there, also the same. What that implies is they're going to cancel out. This will cancel with that one and this will cancel with that one. So when you do that, what we are remaining with here is the hydronium ion on this side multiplied by the hydroxide ion on the other side. So this implies to say Ka multiplied by Kb is giving us the hydronium ion concentration multiplied by the hydroxide concentration. Now, when you see what we have here, the concentration of the hydronium ions multiplied by the concentration of the hydroxide ion is the same as what we have for Kw. Kw is equal to the concentration of the hydronium ions multiplied by the concentration of the hydroxide ion. So what this means is that we're going to say that the concentration of the hydronium ions multiplied by the concentration of the hydroxide ions, this is equal to Kw. Therefore, Ka multiplied by Kb is equal to Kw, like that. Hence, it has been proven. So yeah, this is how we prove to say Ka multiplied by Kb is equal to Kw by going through the process that we have. So it goes like this. You get your acid, put it in water, write its Ka expression, get the conjugate base produced, put it back in water, you write its Kb expression, then you put water into water, then you write its Kw expression, and then you multiply Ka by Kb, and you find out that your Ka multiplied by Kb is equal to Kw.